Hey Science Nines, today we are going to learn about the atom. We did our atomic theories, we kind of know where we are at now, but we are going to focus today on identifying how many protons and neutrons and electrons are in a variety of atoms. You should be able to draw and explain a diagram of the atom, and you should explain how the structure relates to properties of elements. Okay. So you are going to need your periodic table in order to do this, otherwise your life becomes very confusing. So your teacher should hopefully have given you one of these guys. So we are going to look for your atomic number. Now, if you are looking at your periodic table, each periodic table looks a little different. It doesn't quite look like what is on the screen here. It looks like this. Okay, so if you were to find copper, you are going to see a number in the top right-hand corner for copper, which should be 63.55. This is your atomic mass. It is always your biggest one. Your atomic number is in the top left-hand side over here. And then this is obviously your symbol for copper, and then the name will be down below it. There are two other numbers in the top right-hand corner just below the atomic mass, and those are charges. We learn about those more as we go on to ionic compounds and what they mean. So I'm going to have you look at your periodic table, and if you'd like, you can pause and play as you want to try and find these, or you can kind of just bear with me as I kind of find them as well. So we are going to try and find the atomic number for gold. So you are looking for gold now. Got to be careful. Your periodic table doesn't always use the same letters. So gold is not G, it is AU. So if you find gold, it should be an atomic number of 79. And carbon is C, the symbol. So we should be able to find carbon. The atomic number should be 6. Aluminum should be 13. Like I said, copper, the mass is 63.55. But if you find copper, it should be an atomic number of 29. Tin is also another tricky one. It's not a T, it's not a TI, it's SN. So SN, tin should be 50. Potassium is K, and it should be 19. Europium should be 63, and zirconium should be 40. Okay? So the more you do this, the more familiar you will get with your periodic table and finding where they all are. So the atomic number tells us a couple things. The first thing it tells us is the number of protons in the nucleus. Our protons are our positively charged particles, and we often use the symbol, okay, P with a little plus sign in the top right-hand corner. So P stands for protons, the plus stands for the positively charged part, okay? This is what helps us distinguish between each element on our periodic table. The number of protons is different for every single element. Okay, so if we are trying to find the number of protons in chlorine, we need to find, therefore, the atomic number. So the atomic number tells us the protons that are in there. So we are looking for chlorine. Now to make you look a little bit and reflect on what we learned about our periodic table and how it's organized, chlorine, if you're trying to find it, should be in your period 3, group 17. Okay, so your atomic number is 17, which means you have 17 protons in chlorine. Sulfur, also in period 3, is 16. Phosphorus is 15. There's 14 protons in silicon. In lithium, we are looking in group 1. Okay, so lithium should be a number of 3 protons. Sodium is 11, also in group 1. And we have potassium, which is 19. Okay. The atomic number also actually tells us the number of electrons orbiting around the nucleus. Electrons, the symbol we often use to represent that is E with a little negative sign, because electrons are negative charged particles. The number of protons has to be equal to the number of electrons in order for an atom to be neutral, which means it has absolutely no charge. We learn what an ion is as we continue into our lessons. Okay. So now the atomic mass is the number of protons and the number of neutrons. So this is the big number I was talking about. It has the decimal on it. The electrons don't actually count in the atomic mass number because they're so tiny. They are not relevant to the mass. The mass includes protons and neutrons, and when we are looking at in general, those are always found in the nucleus of the atom. So in order to find the neutrons, which is our neutral charged particle, okay, so that means no charge, we are looking at your atomic mass. Okay, we round it because it's always a decimal, so rounding, just a little reminder, 5 and up, you go up, 4 and down, it stays the same. So if we have nitrogen and we have the atomic mass of 14, we would actually end up keeping it the same. We wouldn't round it up, it would just be 14. So if we were looking for the number of neutrons in nitrogen, we would say 14 minus the atomic number, which is 7, and that tells us there are 7 neutrons. Okay? So overall, we need to remember a couple things. So this is really important. I always have my students write this down. So we are going to say, if we are looking for our number of protons, we need to look at the atomic number. Okay, your number of electrons is also the atomic number. Forgive the writing, I am still getting used to this thing. And your number of neutrons, if we were looking for them, we are going to say it's the atomic mass, rounded, minus the atomic number. Okay,